In this video, we're going to be looking at how to solve inequalities. Now, this should be just a review for Algebra 2 students. So let's go over some of the basics on just graphing it on a number line and doing interval notation for those values. Now, when you're graphing an inequality on a number line, if you had less than or equal to or greater than or equal to a certain number, you're going to use a closed dot on that number. If it was not or equal to, you're going to use an open dot on that number. Interval notation, if you have less than or greater than, that's the open circle, you're going to use a parentheses for that value. You also use a parentheses if it goes to infinity. If your dot was closed, meaning it could be equal to that number, you used a bracket. So for example, x is greater than or equal to 8. Greater than or equal to means I have a closed dot. And a little trick, if your variable is on the left side of your inequality, your arrow will follow the same direction as your inequality, but only if your variable is on the left. Now, let's look at the interval notation for that. Remember, interval notation, you go from the left to the right, small to big. So here, as I go from left to right on the number line, the first thing I reach is 8. And because it's closed, I use a bracket. Then my graph continues to the right without limit. It goes forever to infinity. Infinity has parentheses with interval notation. This example, x less than -1, we have an open circle at -1 because it's not or equal to. Less than means it's going to go to the left, and then we have our interval notation. So going from the left to the right, the first thing I hit is that arrow, meaning it goes left forever. It gets smaller without limit. So we say it starts at -infinity. And it continues going until we get to -1. Because this is open, we use a parentheses to close it. Now, solving inequalities. Solving an inequality is not really any different than solving an equation, except that if you multiply or divide by a negative, you must flip the inequality around. So let's look at this first example. You solve it like you would an equation, which means I'm going to start by distributing. Now, when I say up here multiply or divide by a negative, what I mean is when you multiply or divide both sides of the inequality by a negative. In this case, multiplying by this -2 is not going to change the inequality because we're not affecting both sides. We're only affecting the right side. So we bring the left side down, 12p plus 52 greater than, and then over here we're going to distribute. We get -8 plus 4p. Now I'm going to move my variables to the left side. When I'm doing inequalities, I always move my variables to the left to make graphing the number line easier. So I'm going to subtract 4p from both sides, which is going to cancel it out over here. And I'm going to combine it with the next step, which is to move the 52 over. So I'm going to subtract 52 from both sides, which cancels it out over here. This gives me 8p greater than -60. When I divide by positive 8, I get p greater than -7.5. So let's graph this on a number line. On a number line, I'm just going to do -7.5 here. You can do -6 and -8 here, or -7, I'm sorry, if you want to. Usually I'm okay with, when you're hand drawing it, just do your middle line. Now, it's an open circle because it's just greater than. And it's going to go to the right. For the interval notation, going from the left to the right, the first thing I hit is my open circle, so parentheses, negative 7.5. And then it continues right without limit, so it goes to infinity. That's the interval notation. In this one, when I go to solve it, the first thing I'm going to do is I'm going to distribute that negative 4. Or I'm sorry, distribute this negative to the 4 and the 1. Remember, if it's minus a set of parentheses, you're subtracting the whole thing. So it's kind of like you're distributing a negative 1. So that's 3 minus 4m minus 1 is greater than or equal to 5m minus 25. Now my next step is to combine like terms on this side. 3 minus 1 gives me 2. Next, I'm going to move my variables to the left side. Again, I'm moving them to the left even though it's going to make it positive because it ends up easier when I go to do my number line. So 5m's cancel over here. I'm also going to go ahead and subtract 2, which gives me negative 9m is greater than or equal to negative 27. Now when I go to get m by itself, I'm going to have to divide by negative 9. And what you have to be careful on is you're dividing by a negative, which means it flips the inequality. So it's now less than or equal to 3. So there's our inequality. Let's graph it on a number line. So there's 3, 4, and 2. It's less than or equal to 3, so I'm going to have a closed dot on 3, and it's going to the left. The interval notation for this, it starts at negative infinity because it doesn't really have a starting point. It ends at 3, and we use a bracket on the 3 because it was closed. And when you're dealing with single inequalities, you sometimes have a special case. Just like when you solve equations, you can have special cases. They don't look like special cases at first, so you just go through and you solve. So here, I'm going to distribute the 3 on this side, which gives me 24x minus 27. I'll distribute the 4 on the other side, which gives me 24x plus 4. Now if I subtract 24x from both sides to combine my x values, it cancels out the x's on both sides, and it leaves me with negative 27 is greater than 4. Well, negative 27 is not greater than 4. This is a false statement. Because it is a false statement, the answer is no solution. If your answer is no solution, there's not really a number line for it. It is equal to the empty set. That's what this is. It's null set or empty set. It means there's nothing in it. There's no solution in this set of answers. This next one is also a special case. First thing I'm going to do is I'm going to distribute here. Remember, it's like there's a little invisible 1. So the left side I'm going to bring down the 6x, and then I'm going to distribute the negative 1 to get minus 3 plus 5x. My next step is to combine my like terms on this side. So 11x minus 4 is less than or equal, and over here I have 6x plus 5x to get 11x, and then bring down the minus 3. Next, I'm going to combine my x's. I'm going to subtract 11x from this side and from this side as well. And what that does is it cancels out my x values. 11 minus 11 is 0. And I'm left with negative 4 less than or equal to negative 3. Well, negative 4 is less than negative 3. This is true. This means the answer is all real numbers. You can do a number line for all real numbers. A number line for all real numbers is just a double arrow. Okay. Interval notation for this, it starts in negative infinity and goes to positive infinity. So that's my answer, my number line, and my interval notation. So we've been looking at single inequalities. The next thing we're going to talk about are compound inequalities. A compound inequality is when you have two or more inequalities on the same number line. We're going to only be looking at two on the same number line. Now there are two types of compound inequalities. The first type we're going to look at is the OR type. So for instance, on this number line, this inequality tells me that x is less than or equal to negative 4. This inequality tells me that x is greater than 1. Well, it can't be both. You can't have a number less than negative 4 and bigger than 1, so it's an OR inequality. For the interval notation on these, what you want to do is go left to right, same as before, and you take it in stages. So interval notation for just this piece. Okay, it starts at negative infinity. And as we go to the right, this piece ends at negative 4. And close that with a bracket because it's closed. So this inequality is represented by this interval notation. Or there's a symbol for that. It looks like a big U. This symbol means OR. Then we look at this inequality. This one starts at 1 and it's open, so we use a parentheses, and it goes to the right forever, so it goes to infinity. So when you do the interval notation for these, just take it in stages. Now the solving part, it's really not that much different from just a single inequality. It's just you've got two you have to solve. So for instance, in this one, I have to solve both of these inequalities. So starting here, I'm going to start this problem by subtracting 8, giving us negative 3y less than or equal to negative 15. Divide by negative 3 gives me y greater than or equal to 5. Remember that multiplying or dividing by a negative flips your inequality. So that's my first inequality. My second inequality, I start by adding 3 to both sides. So I get 10y less than or equal to negative 30. When I divide off the 10, I get y less than or equal to negative 3. So these are my inequalities. Now let's graph them on a number line. Alright, so negative 3, 2, 1, 0, 1, 2, 3, 4, 5. Okay. So for y greater than or equal to 5, I'm going to have a closed dot at 5, and it goes to the right. For less than or equal to negative 3, I have a closed dot at negative 3, and it goes to the left. That is these inequalities graphed on a number line. For the interval notation, remember you take it in stages. So look at just this one first. This one starts with an arrow, so it starts at negative infinity. And that looks, I wrote a -8. Let me try that again. There we go. This section ends at -3. And because we're equal to, it's closed, we end that with a bracket. So that's this one. Or it's this one. So this inequality, it starts at 5 and goes to the right forever, so it goes to infinity. So this is the interval notation for this graph and these inequalities. One more example with this type. I have two inequalities here, same as before. So I'm going to start by solving this one. First thing I need to do is I multiply both sides by -3. This gives me 8 minus x greater than or equal to 15. So two things. One, remember that multiplying by the denominator only cancels out the denominator. It does not change the numerator. Your top values stay the same. Remember that when you multiply by a negative, you must flip the inequality. So now, my next step would be to subtract 8, which gives me -x greater than or equal to 7. Not quite done with this one, because I don't want -x. If I divide both sides by -1, it will give me a positive x. Remember to flip the inequality, because it was divided by a negative. So x is less than or equal to -7. So over here, the next thing the next step is to solve this one. The first step of that is subtracting 5 from both sides. So we have -3/2 x less than -6. Now we need to get rid of the fraction on this side. We need to move it from this side to the other side. And we do that by multiplying by its reciprocal. So we're going to multiply by -2/3. Do the same thing on the other side. So what ends up happening is this produces the 1, so I just have 1x greater than, because I multiplied by a negative. And over here, multiply, and I get 12/3, which gives me 4. Those are my two inequalities. So let's graph it on a number line. And I'm going to do -8, 6, 4, 2, 0, 2, 4. Okay. So, starting with this one, x is less than or equal to -7. I'm going to have a dot at -7. Less than or equal to means that line is going to the left. On the other side, x greater than 4 means I have an open circle at 4 and the graph goes to the right. The interval notation of this, we start here, go left to right. It starts with the arrow, so it starts at -infinity. This section ends here at -7. Because it's closed, we use a bracket. Or, over here, it starts at 4 and it's open, so use a parentheses, and goes right forever to infinity. Okay. So those are OR type compound inequalities. The other type is an AND. So in this one, the two inequalities went in opposite directions away from one another. In this one, they go towards one another and overlap. So this is, as an inequality, this is saying that our x values are greater than or equal to -2, because it's -2 or bigger, and x is less than 4. The interval notation for this is very short. Remember, interval notation is your smallest to your biggest. My smallest number is -2, bracket, because it's closed. My biggest number is 4, parentheses, because it's open. That's your interval notation for this number line. So sometimes on the and types, you're going to see it written kind of like this: inequality and another inequality, like my first example. So when it's separated like this, you solve it just the same way we did the ORs. Solve each individual inequality, graph it, do your interval notation. So I'm going to start this by subtracting subtracting 3 from both sides to get 2x greater than -12. Divide both sides by 2 and I get x greater than -6. Now I'll solve the other inequality. I start by adding 2 to both sides. I get 8x is less than 32. When I divide both sides by 8, I get, I just forgot how to divide. 32 divided by 8 is 4. There we go. And it's not an or, it's an and. Sorry, y'all. So these are my two inequalities. Now if I were to put these on a number line, okay, 8, 6, 4, -2, 0, 2, 4, that's good enough. Okay. If I were to put these on a number line, I have an open circle at -6, open circle at 4, and it's between them. My interval notation for this is parentheses, -6, comma 4, parentheses. Because it starts at -6, ends at 4, both of them are open, so they both have parentheses. Now you'll notice that my next example looks a little bit different from what I have here. It's written in a condensed form, and I can write this in a condensed form as well. These two separate inequalities I can write together in one. -2 is less than or equal to x is less than 4. This is telling me that x is somewhere between -2 and 4. This is written in the same way. Now, I've seen students in the past, as just a guide, when they're solving equations, they'll kind of do a line wherever they see the equation, so it helps them divide the two sides. Something similar can be done here. I have two inequalities, so I've got basically 3 sections. And anything I do to one section, I must do to the other 2. So the goal is to get the variable by itself. So the first thing in getting the variable by itself in this middle part is to subtract 4. And I have to do that on the 2 end pieces as well. So this is going to give me 0 less than 3p less than 15. Next, to get p by itself, I divide by 3. And I do it on the outside parts as well. So this is going to give me 0 less than p less than 5. That is my inequality. And it's written in the condensed form just like this was. So now let's put it on a number line. 0, 1, 2, 3, 4, 5. Okay. So on both of these, we're going to have open circles because it's just less than. And it's between them, so I just connect my dots. The interval notation for this is parentheses 0, 5 parentheses. Last example. So just like before, if it helps, you can kind of separate them into sections. But just like before, what you're trying to do is you're trying to get your variable by itself in the middle piece. So with this, the first step in doing that is to multiply by -2. I do that on the right side and the left side as well. And remember that multiplying by the -2 here, the only thing it does is it cancels out the denominator. So now I have positive 10 greater than or equal, because I multiply by a negative, don't forget it flips the sign, 12 minus x greater than 4. The next step in getting x by itself is to move the 12 by subtracting. (10 minus 12 gives me -2, greater than or equal to -x, greater than -8. Last thing, I don't want -x. So I'm going to divide each piece by -1. This is going to give me positive 2 less than or equal to x less than 8. That is my inequality. If I were to graph this number, this inequality on a number line, all right, 2, 4, 6, 8. All right. If I were to graph this on a number line, I would have a closed dot at 2, an open dot at 8, and the line connects between. Again, closed because it's or equal to, open because it's not. For the interval notation, it starts at 2, ends at 8. 2 is closed, so you use a bracket. 8 is open, we use a parentheses. Hopefully a lot of this seemed familiar because it is something Algebra 2 students have looked at before. And we're doing this because our next topic in this unit is absolute value inequalities. And absolute value inequalities come out to be compound inequalities on a number line. So that's why we're reviewing these skills.